Hi, welcome to Ready Classroom Lesson 28, Session 3. This is our refine session. It's taking everything we've learned so far about two-dimensional figures and putting them into categories, and we're going to show what we know during this refine session. It's actually not very long today. It's only 5 questions. It's on pages 583 and 584 in your Ready Classroom Math Workbook. I'm not going to go over the problems with you today. I'm going to go over the problems with you, but I'm not going to help you solve them. As you're working, if you have any questions, you can always email your teacher. I also wanted to point out that if you don't know what the attributes of a shape are, you can use your glossary starting on page A1 at the back of your book, and you can look up the different words. If you don't know what the attributes of a pentagon or a hexagon is, you can go to the back of your book and look up the word. So if I wanted to look up a hexagon, for example, I would go to the H section. I would find the word hexagon. I would read the definition. It's a polygon with exactly 6 sides and 6 angles. And then I would see an example of what a hexagon looks like. And so if there's ever any words you don't know, go ahead and utilize those tools you have in the back in your glossary. A regular polygon, so number 1 says this: a regular polygon has all sides of equal length and all angles of equal measure. So regular polygons have equal sides and equal angles. Which shapes below are subcategories of regular polygons? Explain. So you want to tell me which of these shapes, you're just going to, you'll circle the shapes and then tell me why, but which of the shapes have all equal sides and all equal angles? Number 2, a tree diagram can use 2 lines to show subcategories that do not overlap. So for example, we have triangles. You can have scalene triangles, isosceles triangles, and then equilateral triangles. Now we know that neither of these are a scalene triangle, but but it's still a triangle. Okay, so all of these 3 are still triangles, but a scalene is very different from an isosceles or an equilateral. Jose drew these 2 diagrams to show how categories of triangles are related. Are his diagrams correct? So I already told you in a way that this one is correct. Is this one also correct? Do you have the most general in the shape on the outside and then the most specific on the shapes on the inside? And do they overlap or are they separate? So do both of these show similar information? Number 3, describe the attributes of a shape that is both a rectangle and a rhombus. Name the shape and use the grid to draw an example. So we know that rectangles have 4 sides with 2 sets of parallel sides, and I would add 4 right angles. We know that a rhombus has 2 parallel sides and 4 equal sides. So those are the attributes of both a rectangle and a rhombus. What is a shape that is both a rectangle and a rhombus that has all these attributes? It's the most specific. I want you to name the shape and then draw the shape in this box here. Remember, it is the most specific. On number 4, Jake makes a tree diagram to show a hierarchy of polygons. So we have polygons, quadrilaterals, pentagons, rectangles, parallelograms. Explain why Jake's tree diagram is not correct. Then explain what changes are needed. So tell me what in here doesn't belong, and then tell me how you could fix it. Then in part B, you're going to draw a new tree diagram or a Venn diagram. You get to pick tree diagram or Venn diagram to show the hierarchy of these 5 shapes and how they would go together so that they still it still makes sense. And I will tell you that polygons are going to be on the top, or they're going to be the most general. And then the most specific is going to be whatever you find the most specific. This one's pretty messed up, and there's might even be some shapes that need to be in a different there's definitely some shapes that need to be in a different location. Finally, for number 5, it says, are rhombuses a subcategory of parallelograms, or are parallelograms a subcategory of rhombuses? I want you to think about what you know about parallelograms and rhombuses, and then decide which of those is the most general. That means it will be the category. And which one is the most specific, which will be the subcategory. And believe it or not, with that, that is the end of this lesson in math. If you have any questions, you can email your teacher. Otherwise, I'll see you next time.